Hello everyone, welcome back to this channel. In the last video, we have solved a problem longest substring with at most k distinct characters. In that problem, what we controlled was that how many number of distinct characters are there in a particular window. We said that a window is valid in case if the number of distinct characters are less than equal to k. But in this video, the problem we are going to solve is we are going one level deeper and we are not going to take this flexibility of the distinct characters or k distinct characters. In this problem, we are not going to allow the repeated characters or the duplicate characters. And this is where the sliding window problem, this new problem, feels more conceptual. And also, I want to say that this is not a new problem, it's just a same pattern problem, just with a stricter invariant, or I can say a sharper condition that you will get to know when following along in this. So, this is the problem which we are going to see. Now, first of all, let's reconnect or let's recall the last video which we have solved the problem and the problem we have solved. The problem was about at most k distinct characters, and there we said that a particular window was invalid in case if the number of distinct characters goes beyond k. And in that case, we have to shrink the window in order to rebuild it to have in the valid form. And for the valid condition, obviously the number of distinct characters has to be less than equal to k. What I'm trying to say is that in any of the sliding window problem when we solve, we only have to know about one thing, that when the window will be when the window will be valid or when it will be invalid. So in the last problem, what we did was that, that when the number of distinct characters are going beyond k, at that time we have to shrink the window in order to rebuild it to its valid form. The same thing we have to do in this problem as well, that we have to only change the invalid condition for the particular window, that whenever it becomes invalid, we have to rebuild it to its valid form. So that's what the small thing we have to do. And from this, we get to know that any of the problem, like based on the same pattern, the number of problems when we solve on the same pattern, they are only having the small condition changes or the smaller invariants which we have to change. So that's how the things work, and this is how the patterns evolve. So this is the problem which we are going to see, and let's firstly read this problem statement and we will move ahead. So the problem we are talking about is the longest substring without repeating characters. It means no any character should repeat or no any duplicate character should be there in a particular window or a substring. So we are given with a particular string s, and we have to return the length of the longest substring that contains no duplicate characters. And a particular example which we are given with is the input abc abc bb. This is the input string we are given with, and we will just perform a dry run based on the logic whatever we will be understanding. So the explanation is simple, given that here abc, this is the particular string which is having the distinct characters but no any repeated characters or any duplicate characters. So abc is the longest substring we have found in this particular input string without any of the repeated characters. Okay, so this is the problem statement we have just saw, and now let's try to understand that how we can solve this problem. So first of all, we know that we have to find the length of the longest substring that contains no any duplicate characters. It means no any character should repeat in a particular window or in that substring. So what we have to do is, in the last problem as we did for the distinct characters, that there should be at most distinct characters, k distinct characters. In this problem, we have to see for the characters, not for the number of, or not for the count of the types of characters. We have to think for the frequency of each character. So what we can do is we have to check the frequency of every character. Like in the last problem, we have saw the how many number of distinct characters are there in a particular window, and if they goes beyond k, then we have to shrink the window in order to make it again valid. But in this problem, we have to see that if any of the characters frequency goes beyond 1, because we only want the single characters, not the multiple characters of the same type or the repeated or the duplicate characters. Instead, we have to see for the characters with the frequency 1, and if that particular character's frequency moves beyond 1, then in that case we say that the window will be invalid. So what is the invalid condition in this particular problem? That whenever the characters, any of the characters, like if we are having a particular window, and in that particular window any of the characters frequency goes beyond 1, in that case that particular window becomes invalid, and we have to then shrink that particular window in that case in order to rebuild it to its valid form, so that all the characters in that particular window are having the frequency of 1. So that's what we have to do. So what will be the condition in this? The invalid condition will be like invalid condition invalid, I should say invalid window condition. So invalid window condition will be what? uh, a condition will be like that, in case if the frequency goes greater than 1. So this we have to do for every character. Any of the characters frequency goes greater than 1, then in that case we have to start shrinking the window until it becomes again valid, means until all the characters are having the frequency of 1 or less. So that's what we have to do. Now from this what we can understand is that all the sliding window problems, uh, whatever are those, they are not about the pointers or something. They are about that, they are about like deciding the invariants. If we get to know that what is the invariant for a particular problem, like for this particular problem we know that a window will become invalid in case if the any of the characters frequency goes beyond 1, then in that case we have to solve for that. Now this condition which we have saw, like there can be any other problem also. For that the invariant will be different. So only the invariants, or we can say the conditions for a particular problem changes, rest of the logic or the structure of the problem remains the same. So that's how the patterns grows, and that's how we solve the multiple problems on the same pattern. So this is the invalid condition for this particular problem. And also we can see can notice a subtle shift in this particular problem, that in the last problem we were counting for the number of distinct characters. Like there will be multiple characters of the same type, but we were counting for the number of like counting the types of characters. But in this problem we are counting the frequency of each character. So that's how the control, a level of control we are building in this particular problem. So this is the logic of this problem. And let's now go to a dry run, and we will see in more detail that how we have to solve this particular problem, and also we will get a complete intuition of this problem. So this is the example I have taken, the input string which is given in the problem. So this is the input string which we are having. Now this string of size 8 is there, and the string is ABC, ABC, and BB. So these are the 2 pointers. Again, as I have also already mentioned, the sliding window is not about the pointers. It is more about the deciding of the invariants, like how we decide the invariants for a particular problem. Like for the different problems, there will be different conditions or the different invariants. So that's how we have to think. So for this particular example, let's try to dry run on this. So now we will be taking a frequency map. And now what is the purpose of frequency map? So frequency map will tell us that every character's frequency, and at every point we will be checking if any of the characters frequency is greater than the 1, then we will start shrinking the window. So let's start with the dry run. This is the frequency map I have taken here, and let me just call it as frequency map. This is the frequency map I have taken, and because we have to get the length of the longest substring, so we will be taking a max length variable in which we will be updating the length of the substring every time if it is maximum in that case. So this is the max length variable I have taken. Now starting with the right pointer, wherever the right pointer is pointing, we will be starting from there. So first of all, right pointer is pointing at this character A, so we will take this character and put it inside the frequency map. So this character is taken, and along with its frequency count of 1. And now once it is taken in the frequency map, now what we will do is, the moment it is taken, we will check if this right pointer, wherever it is pointing, if its frequency is greater than 1. In that case we will start shrinking the window. So right now this right pointer is pointing at this character A, and its frequency inside the frequency map is 1. So therefore we will not be doing anything, because we know that right now the window is having the characters, all the characters with the frequency of 1. So we will not be doing anything, and we will just go forward, and we will just update the length of this particular substring for based on this window. So right now what will be the length of this window? That will be right minus left plus 1. So this is 0 minus 0 plus 1, and right till now the maximum length we got was 1. Now we will move this right pointer ahead. So when this right pointer moves ahead, it checks for another character, and this is the another character B. It will be now taken inside the frequency map along with its frequency count. So it is now for 1 time. And now once it is taken inside the frequency map, we will now check if its frequency count inside the frequency map, we will see if its frequency count is greater than 1. So again we can see its frequency count is only 1, and we can see till now whatever the number of characters are present in this particular window are all are having the frequency of 1. Okay, so right now its frequency is 1, so therefore we will not be doing anything, and right now the window is valid, so we will take the length of that window. What will be the length? Length will be 2. So max length will be updated with the value 2 because it is maximum. Now right pointer will move ahead. Right pointer moves ahead and it checks another character. It is the character C, and it will be taken inside the frequency map with its count. So this is with the frequency count of 1. And again, it will check that if this character's frequency inside the frequency map is greater than 1. If it is greater than 1, then the window will be invalid. But because it is 1, so therefore the window is valid, and we will take the length of this window into consideration. So what is the length of this window? Length of this window is 3. So now the 3 values updated inside the max length. So what we can just notice from here, we can observe one small thing here, that every time this right pointer, whenever is pointing at a particular position at a particular character, it is checking at every moment that if the particular character's frequency is greater than 1 or not. This is how it is checking every character. So now this right pointer moves ahead, and it will now check for this another character. This is A. And inside the frequency map, its frequency will be updated with 2 because it is found for second time. And now when this right pointer checks this character's frequency, it is found greater than 1. Right now this particular window is invalid because it is having a particular character, a character, with 2 times. So right now this particular window is invalid, and now we will start shrinking this particular window with the help of left pointer. So this is where the left pointer is pointing, and now we will start shrinking. So while shrinking, what we will do, this character's occurrence, one of the occurrence will be deleted, or we can say removed from the frequency map or from the window. So once it is deleted, this A will be, this one occurrence will be removed. We have removed one of the occurrence of this particular character from the frequency map, and now we will have to check if at whatever character this left pointer is pointing, now we will have to check if its frequency is 0. Then in that case, we will have to remove that particular character from the window or from the map. So right now this character's frequency is 1, so therefore we can just take this left pointer and move it ahead. Okay, and now when the left pointer moves ahead, now again we will have to check if this frequency of the right pointer, means wherever the right pointer is pointing, if its frequency is still greater than 1, then we will have to again do the same thing like shrinking the window. But right now its character's frequency is equal to 1, therefore the window is valid, and we can take the length of this window into consideration. You can see this particular window is having all the distinct like that characters with the frequency 1. So we can again take the length of this window, and the length is 3. So right now the maximum length is still 3, so no problem. Now this right pointer moves ahead. When this right pointer moves ahead, it will check for the character B, and this B's frequency will be increased to 2. And right now we can again see that this particular window is again invalid because it is having B 2 times. So therefore we will again have to shrink, and with this left pointer we will take this character, remove one of the occurrence of this particular character from the frequency map. So this character's frequency will be removed, one occurrence will be removed, and it will be 1. And now we will check if this particular character's frequency is equal to 0 or not. So it is not 0. So therefore we do not have to do anything, and we can just take this left pointer and move ahead. And again we can check for the this character's frequency, that if this right pointer wherever it is pointing, if its frequency is if it is greater than 1, then we have to shrink it. But because it is 1, so again we can see that this particular window is valid right now, and we can take the length into consideration. That is again 3, and maximum is 3 still. And now this right pointer moves ahead, so it will now pointing at the character C. And now when we take its frequency in the frequency map, so the C's frequency will become 2. And now because its frequency is greater than 1, so again we will have to shrink this window with the help of left pointer. So the C character's frequency will be removed, one of the occurrence will be removed, so this will now become 1. And because its frequency is 1, it is not 0, so we do not have to remove this from the frequency map. So we can just take this left pointer and move ahead. And once we moved ahead, now we can again check if its frequency is greater than 1 or less than equal to 1. So because it is 1 only, it's not going beyond 1, so therefore the window is again valid, and we can take the length into consideration. So it is again 3 only. So maximum length is 3 till now, and therefore we can take this right pointer and move ahead. Now this right pointer is pointing at this B character, so this B's frequency will be increased to 2. And now we will check the window validity. So because the B's frequency is greater than 2, so therefore we will have to shrink this window. Right now this left pointer is pointing at this character A, so now it's one of the occurrence will be removed. So when its occurrence is removed, it will now become 0. And now we can check that this age frequency is equal to 0, therefore we have to remove this particular character from the frequency map. So for that, we can just remove this character A from the frequency map. Now we can see that this A character is removed from the frequency map, and therefore this left pointer will move ahead. And once it moves ahead, now we will again check if this, with the help of right pointer, if this particular character's frequency is greater than 1 or not. So because this B's character frequency is greater than 1 still, so therefore again we will shrink this window. And because this left pointer is pointing at this B character, so the occurrence of one of the occurrence will be removed, and this will now become 1. And because it is 1, it is not 0, so no need of removing this particular character from the frequency map. So we can just take this left pointer and move it ahead. Now we can check the window validity again. So this right pointer is pointing at this B character, and its frequency is equal to 1 right now, so therefore this particular window is valid in this case. And we can just take the length into consideration, so it will become 2. And comparing with the previous maximum length, it is the maximum is 3, so therefore we need not to update it. And after this particular right pointer will move ahead, and it will again check this character B, and its frequency will be increased to 2 again. And when we check the frequency of this B character, so because it is greater than 1, so we will have to shrink this window again, and this C character's frequency will be, or we can say the one of the occurrence will be removed, so it will now become 0. And because its frequency is 0, so it will be removed from the frequency map. And once it is removed, what we will have to do is, first of all, this C character is removed from this frequency map, and then this left pointer will move ahead. And once it is moved, we can then again check for the window validity. So because this right pointer is pointing at this character itself, B character, and its frequency, we can see it is greater than 1 still, so we will have to again shrink this window. And once we will be shrinking, this B character's frequency will be, or we can see one of the occurrence will be removed. So this is removed, and now we can see that its frequency is not 0, so no need to remove it. And we can just take this left pointer and move it ahead. And after moving it, we will check with the help of right pointer that if its frequency is 1 or not. So because it is 1, so again the window is valid, and we can take its length. So maximum is 3 only, so no need to update it. And then this right pointer will move ahead, and once this right pointer moves ahead, we get to know that now no more window is valid, so therefore we can stop this process. So this is how we have seen that the maximum length we got of a particular substring. And what substring we got, we can see there are multiple substrings. Like this is a one substring which is having the length of 3, is having all the characters without any repeated characters. And we can also see that this particular window is also there, ABC. Okay, so and this BCA is also there, CAB is also there. So this is how multiple substrings are forming for the length 3, which is having that the different characters without any repetition, without any duplicate. Okay, so this is how we got the length of the substring, the maximum length, that is 3. Now one of the important part which I have to cover here is that you can think of that how many times we have to shrink this particular window. Like either we have to shrink once, or we have to shrink the different times. So let me just take a simple example here. I will be taking an input string. For input string is that A B, right here, A double B. So this is the input I have taken, and if we try to have the length of the longest substring of, from this particular input, so what we can do is, first of all, this left and right pointer will be pointing at this A character. So with the help of right pointer, what we will do is, we will first of all take this frequency of this particular character A inside the frequency map. So let me just take a frequency map here. This is the frequency map, and I am just taking the count of this, sorry, the frequency of A character. So A is present 1 time right now. So I have taken this inside the frequency map. Okay, and now I will be checking if this character's frequency is greater than 1. So because it is 1, therefore the window is valid, and I can just take the length of this window into consideration. So max length I can take here, and right now that will be 1. Now this right pointer will move ahead, and because it sees a character B, and now I will be taking this B character inside the frequency map, so it will be taken 1 time. And because its frequency is also 1, so therefore the window is valid, and I can just take the length into consideration, so that will become 2. and when this right pointer moves ahead, again it will see a character b, so this b character will be taken again, and that frequency will be updated, so that frequency will now become 2. Now when the frequency is checked for b character, so because it is greater than 1, now the window became invalid, and when the window became invalid, we will have to shrink now with the help of right pointer, which will be pointing at this character a. Okay, here the a character will be there where the left pointer will be pointing. So first of all, the a occurrence, one of the occurrence of this a will be removed from this frequency map, so it will now become 0. And because it is 0, so this a will be removed from the frequency map. And once it is removed, what we can see here, that once it is removed and now this left pointer is moved ahead, so this is now pointing at this b character, this left pointer. And once this a is removed, and now we are checking this b's frequency again in order to check the validity of the window. So because this b's character frequency is still greater than 1, okay, so in that case we will have to again shrink this particular window. What I am trying to explain here is that we do not have to shrink the window once, we have to shrink the window until the window is becoming valid again, or until the invariant is restored. So till that point we have to shrink this particular window, not only once, we have to shrink it till the point where the invariant is restored. So here we can see that the double b means b is present 2 times still inside the window, therefore the window is invalid till now, so therefore we will have to shrink it again. So that's what the point I am trying to mention here with this new example. And once it is shrinked again, so again one of the occurrence of this b is removed, so only one b will be left, and then the window will be restored, or we can say the invariant is restored. So that's what I am trying to mention here. So this is the example which I have taken to explain that thing. So this is the example which we have seen for the dry run, and let's now get to the implementation part, and let's code for this particular logic. So what we have to do here is, first of all, let's take the size of this string. So int n equal to s dot size, and once we taken the size, first of all we will be taking the map, that is the frequency map, in which first parameter will be of the character for the characters and another will be for the frequencies. And let me just name it with the frequency map. And once we do this, we will be now taking the maximum length variable, which we will be updating for the answer. And now see, 2 pointers will be there. One of the means left and the right pointers will be pointing at the start index, that is the left equal to 0 and right equal to 0. And now the while loop will be there, which will be running, and this will be running, as I already told, that whenever the right pointer is pointing at the n, means the moment it is till n-1 index, till that point this particular process will run, otherwise we will have to stop. So till this right is less than n, we have to run this process. What we have to do is, wherever the right pointer is pointing, we have to take that particular character and put it inside the frequency map along with its frequency. So this frequency map of s of right, we have taken this and put it inside the frequency map. And once we put it, now we will be putting a particular condition, means a while loop we will have to write, because what we have to do here, we have to shrink the window, means in case if the, see, one thing is there, that in case if the window is valid already, means how we will be checking that thing, with the help of while loop. We will just write a simple condition that if this frequency map of s of right, if it is greater than 1, okay, in case if it is less than equal to 1, then this particular loop will not be running. Directly we will be going at the end, and we will just update the max length. So this max length will be equal to max length comma, how we have to take the length of the window, that will be right minus left plus 1. This is how we have to take, and simply we have to just take this right pointer and move it ahead. Otherwise, if this particular frequency map, means this s of right, wherever it is pointing, inside the frequency map, if its frequency is greater than 1, if it's found to be greater than 1, and in that case the window is invalid, and that's how we have to do. Here we have to shrink the window till the invariant is restored or the window is restored. So for that thing, what we have to do is, we have to just go inside the frequency map, and inside the frequency map, with this s of left, with the help of left pointer, we will be shrinking that particular window. So frequency map of s of left, and we will be just reducing one of the occurrence of it, and once it is done, we will be just putting a simple condition if this frequency map of s of left, if its frequency is equal to 0, then just remove that particular character from the frequency map. This is frequency map dot erase, and what we have to erase is that is s of left. Okay, this we have to do, and then we have to just take this left pointer ahead, move this left pointer ahead. Okay, this is the entire logic, and at the end we have to return the maximum length, the answer which we are updating right till now. So that's what we have to do. So what we understood from this is only this simple condition is changing in this particular problem, or whatever the problem is based on the same pattern. Only this simple condition changes, or this invariant is changes. Means at what point the window will become invalid, that condition we have to write here. The rest of the structure or the logic of the problem remains the same. So let's just take the simple input here. What was the input? ABC, ABC, EB. This is the input string, and let's just perform a run here. Okay, so we can see that the length of the longest substring of the S, whatever the input string we have given here, the 3 maximum length is coming. So this is the length, like ABC or this BCA or CAB. So these are the longest substrings inside this particular string. The number of characters without any repetition or without any duplicate. So let's take one more example, like this, the length of the longest string should come 1. Okay, like the character with no repetition or no duplicate. You can see from here that the length of the longest substring of S is 1 in this case. One important thing which I have to mention here is also we have seen in the diagram and also in this implementation part, in the code part, that in the last video, with the at most k distinct problem, we have seen that we have removed the character if its frequency becomes 0. So we have removed that from the frequency map, because the size of the frequency map matters in that particular problem. And because the invariant condition was that that one, because we were checking the frequency map dot size if it became greater than k. So that's why we removed the frequency of the particular character. But in this particular problem, the frequency map size doesn't matter at all. So, so even if the any of the character inside the frequency map, if its frequency becomes 0, then in that case we need not to remove that particular character. Like it is optional, we can remove it in order for the cleanliness of the code and for the frequency map, but it is just optional. It is not required, or it is not mandatory that we have to remove that particular character from the frequency map if its frequency becomes 0. So this I have removed from the frequency map, but even if we do not write this particular line here, then also it works, because it is not at all required in order to remove that from the frequency. It can stay. Okay, so now we run this, it will work as it is. The length of the substring, the longest substring will be 1. And also in the previous input we have seen AB. So now the length of the longest substring will come 3, as came earlier. So this is the length of the longest substring, there is 3. And now let's talk about the time and space complexity as well. So for this particular uh, code, because all of the characters are leaving and entering the window 1, so therefore the time complexity is O of n, that is linear time. And talking about the space complexity, so for the space complexity, we can see that like in this frequency map, all of the unique characters will be there. Like if the map stores only the unique characters in the window. Okay, so in the worst case, what we can see is that all of the characters are unique. So space is O of n. Like input string is there, which is having all the unique characters. Then that particular size, that space will be O of n. But one more limit is there, that for a particular like for the characters, they can come from the limited set, like the ASCII. So we can't store more than the character size. Also I have mentioned here as well that since the characters come from the limited set like the ASCII, so we can't store more than the char set size. Okay, so it's like that if this n, whatever this n is, if it is less than the char set, then in that case what will happen, the worst case unique, means the worst case unique characters will be the n in that case. And in case if this char set is less than n, then in that case this char set will be the worst unique. Okay, the worst unique in case, this case will be the char set. Okay, so this is how the things work, and in this way we can say that the minimum of whatever the minimum will be there out of this n and the cat set, that will be there, that will be the space complexity. Okay, so this is the space complexity, and time complexity already we have seen that it will be linear O of n. So this is the problem all about, and what we just understood from this problem is that whatever the problems are based on this particular pattern, uh, all the things we have to talk about is about the invariants. Like if any of the another problem comes, like if I tomorrow if I say that we have to solve a particular problem about the longest substring with at most two repeating characters, then in that case we will not be thinking too much. We will be just asking that what is the invariant in this case, what is the condition I have to change in this particular problem. So that is how the things work, and that's how the logic works, and the patterns evolve. So this is how we have solved this particular problem, and in the next video we will be talking about the another problem. We will be moving further in this pattern, because this pattern is not over yet. We will be going further with the other problems as well, and we will meet in the next video. Till then, just keep learning, keep growing, and this is Aditya Patel signing off. Thank you.